Hello, I am Peilang Gong. I'll be discussing our work on augmented contrastive clustering for time series test time adaptation. First, let me highlight the fundamental challenge in time series applications. As shown in this distribution plot, we observe significant domain shifts between training and test data. To address this, UDA methods have emerged, aiming to align feature representations across domains using unlabeled target data. However, traditional UDA methods face a critical limitation: they require continuous access to source domain data during adaptation. This raises significant privacy and security concerns in real-world applications. In response, source-free domain adaptation has been proposed, which operates without requiring access to source data while considering temporal dynamics. Yet, SFDA faces two major challenges in practical applications. The first is the demand for immediate inference in online streaming scenarios, where we must adapt quickly to continuous data streams. The second challenge, as illustrated in the right figure, involves the complex temporal characteristics of time series data, including magnitude variability and non-stationarity. This leads us to our core research question: how can we effectively mitigate these temporal challenges during test time adaptation while maintaining real-time performance? Our proposed solution addresses this through a novel uncertainty-aware approach. Let me introduce our novel methodology, which addresses the temporal challenges through two key innovations. First, we propose an uncertainty-aware prototypical ensemble module that enhances pseudo-label quality by identifying and prioritizing competent temporal patterns. This module processes both raw and augmented input streams through shared encoders and classifiers. Second, we implement an augmented contrastive clustering constraint, leveraging entropy comparison between ensemble and prototypical predictions to improve feature discriminability. The right side illustrates how our approach integrates uncertainty-aware prototypes with contrastive clustering to mitigate error accumulation during adaptation. For empirical validation, we employ a multilayer 1D CNN backbone architecture with adaptive pooling. We evaluate on three diverse time series datasets: UCHA for human activity recognition, MFD for machine fault diagnosis, and SSC for sleep stage classification, encompassing various temporal characteristics and domain shift scenarios. Let me highlight our experimental results on both human activity and machine fault datasets. For the HAR domain adaptation tasks, our method achieves 88.16% average F1 score, showing consistent improvement over baselines across all scenarios. Similarly, on the MFD dataset, we attain 95.6% average F1 score, with notable performance in high-variance scenarios like 0-1 and 1-2. For sleep stage classification, our approach attains a 62.65% F1 score, showing consistent improvement across all cross-domain scenarios. The ablation study reveals the critical role of each component. Among augmentation strategies, our method proves most effective for temporal data. Parameter analysis shows stable performance across different hyperparameter settings. The TSNE visualizations demonstrate superior feature discrimination compared to source models, with clearer cluster boundaries and reduced domain gaps.